Next up, we're going to calculate the child-woman ratio. This is an incredibly easy measure to calculate, and it's quite useful if you don't have any information on births. What you get is something that can serve as a rough estimate of fertility, and in fact is conceptually similar to the general fertility rate. You need the total population age 0 to 4, and the female population during childbearing years plus 5. So if you're using ages 15 to 45 as your reproductive range, you need to go 15 to 49. If you're doing 15 to 49 as your reproductive range, you need to go 15 to 54. This is simply because some of your children who are like age 4 would have been born to women who have now moved up to this age category. The actual result can be kind of hard to visualize. It's a ratio, and it will pretty much always be less than 1. So we're going to go ahead and calculate the child-woman ratio for the United States in 2010. Come over here. All right, so this is going to be the total number of kids ages 0 to 4. So come in here, equals data in that cell divided by, we're going to need the sum of this female population. So I'm going to type in sum, open parentheses, population in reproductive ages plus 5. I'm going to go to 54 on this one, close parentheses, and hit enter. And we get 0.240, so on and so forth. If the CWR is 0.24, this means that for every woman of childbearing age, there are 2.24 children between ages 0 and 4. So you can go ahead and use a constant if that makes this easier to picture. So I'm just going to do equals 1,000 times that. So now what we're saying, and I'm going to change that decimal level because we don't need all that there. In fact, I'm going to drop it down to just straight 240. So for every 1,000 women of reproductive age, there are 240 children ages 0 to 4, roughly. Again, what does that mean? Of course, if we know that for example, the total fertility rate for the United States in 2010 was 2.01, then why do we have this, which is actually fairly low in comparison? Well, keep in mind, we're only looking at children ages 0 to 4. For low fertility countries, the ratio is typically less than 0.3, so that definitely the United States. I could come over here and do the same thing. For Japan, I'm just going to copy, and I'm going to come over here to my Japan spreadsheet, and it was 1 over and a couple down, V. Yep, that got it. It's even smaller for Japan. It would probably be noticeably larger there for Uganda. High fertility countries, this ratio is going to be 0.7 or greater. Really, after 0.5, you're talking about countries with definite population growth. Now finally, I'm going to talk about the gross reproduction rate and the net reproduction rate. And I'll show you the calculations of the gross reproduction rate, but not the net reproduction rate. And that's because it's a little more involved than we want to get into right now. I do want you to understand what they mean. The gross reproduction rate is not interested in how many births per woman in her lifetime, but how many births to females in a woman's lifetime. Essentially what you're saying is a woman going to have children that will then reproduce the next generation. So that's why we're just following down the line of female. Now, it's actually pretty easy to calculate. If you've got the sex ratio at birth, it's just the total fertility rate times the proportion of female births. Now, we don't really have that here, but that's okay. If you don't really have the true ratio, you can always use what's a pretty close approximation in most populations, which is 0.49. So essentially 49% female births. Now there are places in the world in which the proportion of female births is smaller than that. There are pretty much no places where it's higher than that. In general, there are more males born than females by a very small amount. So I'm just going to take this is simple, equals that, so that's my total fertility rate times 0.49, and there we go, rough approximation of the gross reproduction rate for Uganda. And I'm just going to copy that and pop into my United States, where I get a 1, and my Japan, or I get less than 1. So in Japan, at the moment, their gross reproduction rate, as well as their TFR and everything else we see, shows that they are a population who is not able to reproduce itself. In the United States, just. So every woman will on average have, well, it doesn't really work out that way. It's not that every woman has a daughter, but the average for the nation is 1 daughter per woman, which means each generation can successively reproduce itself. In Uganda, very high fertility country, 3 girls per woman. The net reproduction rate is very similar to this, but it multiplies the numbers of births in each age category by the survival rate, or female births in each age category, by the survival rate it would take for that birth to reach that age category and then reproduce themselves. So it's the gross reproduction rate, but it accounts for how many females die before reaching each reproductive age category. It then proceeds to be calculated like the TFR and the GRR and so forth. So it'll be a little bit smaller than the GRR. Not a lot, just a little bit. I have a couple of examples up here, and I need to scroll a little bit so that it all fits inside. There we go. This is just a graph of the total fertility rate and the gross reproduction rate in 1960 through 2002 in the United States. They mirror each other, obviously, because the gross reproduction rate is essentially half of the total fertility rate. If you see these diverge, that's because you're getting a very weird sex ratio at birth happening somewhere or another. Here's another table down here I want you to look at. This is comparing the total fertility rate with, so there's total fertility rate right here. And come over here. Now you'll see the gross reproduction rate. It's roughly half of what we just saw. And then over here, net reproduction rate, slightly smaller. So in 2002, that's this last here, 979, 983. These are using a different constant than we normally think of as total fertility rate. 2013, that's the same as 2.01 children per woman. This is 0.98 females born per woman, and this is 0.979 surviving females born per woman, and so forth. So the net reproduction rate is influenced by mortality in a country. If a country has extremely high infant mortality rate, you're going to see a net reproduction rate somewhat lower than the gross reproduction rate, because many infants and children are not making it to the reproductive ages. So net reproduction rate is also a very good way to look at interrelationships between deaths and births.